Stanford University.
All right, so welcome to lecture number 9. I think it's number 9 for CS193P. And today we are going to talk a little miscellaneous topic at the beginning, just like I did last time. And then we're going to get into the meat of today's lecture, where I'm going to talk about 3 very powerful UI view subclasses. In your homework, you created a powerful UI view subclass called graph view. You can graph arbitrary data. It's pretty powerful, actually. And I'm going to talk about 3, image view, web view, and scroll view today, which are very powerful UI view subclasses as well. And then I'm going to do a little demo, show how to do image view and scroll view. And my demo on Thursday will show you how to do web view. So you're going to get to see it all in the demo as usual. But first, I'm going to take a little time out and talk a little bit about setting a UI's frame. Okay? And really, I'm going to talk about the object in the object-oriented sense, in the design sense, who's responsible for setting a UI view's frame. Okay? And the answer is right here. It is the object that puts the UI view in a view hierarchy. Okay? So whatever object does the add subview that causes that view to join a view hierarchy, really it's responsible for setting the frame. Okay? So let's talk about who are some of the objects that put things in view hierarchies. Well, one of the big ones, interface builder. You're putting views in the view hierarchy all the time. You're dragging them out, UI labels and UI buttons and all, custom views and everything, you're dragging them out. And when you grab the little handles and stretch them out, and move them around, use the guide bars to put them where you want, you're setting the frame in Interface Builder. Okay? So Interface Builder is doing its job. Okay? It's the one putting it in a view hierarchy, and it's also letting you set the frame. So that's good. What about when you do alloc init with frame? Okay? So you don't do this a lot because you build most stuff in Interface Builder, but for example, in this homework you're doing now, you do an alloc init with frame of your graph view because I told you to do it in load view instead of Interface Builder. So if you're doing alloc init view on a view and you're putting it into a view hierarchy right away, well then of course you're responsible for setting the frame because you're building a view hierarchy. You got to say at least where it starts out. Now all these views, whether Interface Builder or not, have stretchiness and struts and springs, so they're going to stretch out and move around as the view resizes. But you got to kind of give an initial layout. And if you're doing it in code instead of Interface Builder, then when you're building that view hierarchy, you're responsible for setting the frame. If you're not putting that view in the view hierarchy, which is pretty darn rare, okay? It's pretty rare to be creating a view and then you don't put it in a view hierarchy. It just sits around. There's one big exception, which I'm going to talk about, where you do this. Otherwise, it's almost unheard of to do that. But the answer in that case is it doesn't matter what you set the frame to. Because if you're creating a view and you're not putting it in a view hierarchy, presumably someone's going to someday in the future. It'll be their job because they're the ones putting it in a view hierarchy. It's their job to set the frame. However, I would recommend that you not use 0, CG-rect 0, as the frame in this case when you're creating a view for someone to do something else later. And the reason for that is that sometimes you'll create a view, it'll have some stretchiness, some strings and struts and stuff, and then someone else will add it to, set its frame and put it in a view hierarchy. And if it was 0, 0 size before that, all the stretchiness is not really going to work because there's no edges for the struts to stick to when it's 0, 0. And so I generally recommend against that. And in fact, when you create a view with alloc init with frame and you're not going to put in a view hierarchy, what frame should you use? I think a good default to pick is UI screen, main screen, application frame. Okay? This rectangle is the entire screen minus any parts of the screen not allowed to be used by an application. Now, in the current implementation of the iPhone and the iPad, the only thing that's not allowed to be used by the application really, and actually the application could use it but is not really supposed to, is the status bar. The little bar at the top that shows you how signal strength and all that. Generally, you're not supposed to make your app use that space. It's not strictly forbidden, but generally, some apps, it would be an edge case to use it. So using that application frame, the reason that's a good default is, it's guaranteed to be a reasonable size. So if you got strings and struts going on there, it's starting at a reasonable, not, pathologically small size, like 1 by 1 or 0 by 0. Also, if someone decides in their application did finish launching with options to just add that view, subview to the window, it'll do the right thing, even if they don't set the frame, which people often do. For example, in this class, when we, in application to finish launching with options, when we've added navigation views and split view controllers views, we didn't set any frames. We just said window, add subview, split view controller dot view. Okay? So why did that work? That really shouldn't have worked because we're supposed to be responsible for setting its frame. We're putting it in the view hierarchy. Well, the answer is that those things like the controllers of controllers, they probably, when they create their views in load view, they probably set the frame to be the application frame. I don't work for Apple. I don't know what's in there, but it sure seems like that's what they do. That's certainly the effect. And you could probably do the same thing, right? So if you're creating a view, in load view usually, that's the one place, I told you there's a big exception, the one place in the code where we create a view that we don't put in a view hierarchy is our top level view in load view. Because we're a view controller, we have that view, it's created, we're ready for someone to go put it in some other place, like in a navigation controller or a split view or a popover or something like that, but we don't put it in there. So that makes sense? Everyone understand what I'm suggesting there? Just so it's kind of the default. It's not required. It's just this application frame. And in the demo today, I'll show you the use of application frame. I'll use it in the demo just to show you what it looks like. All right? Question?
So when you have your view controller's view, when you set it, it doesn't automatically get put onto the stack, I guess?
Yeah, so the question is, when you set your view controller's view, are you talking about in load view? So when you set your view controller's view, like you say self.view equals my top level view in load view, you're not putting it in any view hierarchy. You know, it itself might be a whole view hierarchy, or just one view, like in your homework, but it could be a whole view hierarchy, but you're not actually putting it in any view hierarchy at that point. It's just sitting around, and then at some point you add the view controller, your view controller that's implementing that load view, you add that to a navigation controller or a split view controller or a tab bar controller, and it puts that view on screen, and so it sets the frame, right? In a navigation controller, it puts it in the middle with the bar on top and bottom. In a split view controller, it puts it on the left or on the right. In a tab bar controller, it puts it in the little space above the tab. You see what I mean? It's setting the frame. So, all right, that's all I had to say on that. Any other questions? Okay, so today's topics, these three special views. Before I talk about the first one, which is UI image view, I'm going to go back to UI image and just remind you how you create a UI image. So a UI image is not a view or anything. It just is an object in the kit, UI kit, that represents an image, a JPEG image or a TIFF image or lots of different formats. And the way we create them is either by name. If we drag them into our resources folder in Xcode, we can just create them by name like this. Image named foo.jpg, bam, we got it. Or we can create it with the data. If someone gives us all the JPEG data for an image, we can actually pass that data off to UI image, and it'll look at it all, figure out that it's a JPEG, do all the right things with the bits and everything. It's really quite a powerful class, UI image, because it's able to look at all kinds of different formats and figure out what's going on. Now, where might you get that data? Well, it might be in a file in the file system. And in fact, there's a special UI image class method called image with contents of file. You can just give it the file name and it'll go open the file up, look at the data in there and do it. Or you can actually get the raw data off of the network, like from Flickr, which you're going to do for this week's assignment. You're going to go, for next week's assignment rather, you're going to go to Flickr and actually ask it for an image, and it's going to give it back as a big blob of bits, okay, an NS data. And then you're just going to alloc init and pass that bag of bits to UI image, and it's going to create an image for you. Right? And you don't even care what format that Flickr is. It could be JPEGs, it could be TIFFs, or whatever. You don't care because UI image is going to look in there and figure it out for you. So it's pretty powerful. And then once you have a UI image, you can find out how big is that UI image in points, not in pixels, points, by using this property CG size. Okay, it's read only, and you can ask it how big are you in points. Now, I don't really have time to go into points versus pixels today, but hopefully we'll cover it a little later in the quarter. It matters on iOS 4 because you actually might want to have two versions of all of your images, a high resolution version and a lower resolution version. But when you design your UI, you want them to be the same. Your UI image view, for example, that's displaying it wants to be the same size, but it just wants to have more pixels packed in there when you're on a higher resolution device. And hopefully we'll get a chance to talk about that. But when you ask for the size of a UI image, it's going to tell you the size in points. All right, so you've got a UI image from one of these sources. What can you do with it? Well, I mentioned in a previous lecture that there's some functions that you can use to draw that image in your draw rect. Okay, like, draw image in rect, which will scale it, or draw it at point, which will just draw it with the upper left-hand corner there. But the other way to get it on screen is to ask a UI image view to draw it. Now, UI image view is just a UI view. It's just like UI label or your graph view or any other view. You can drag it out in Interface Builder. You can alloc init with frame it in your code, and you just throw it into a view hierarchy, and it will display an image. Usually we create a UI image view using init with image. All right? And remember that UI view's designated initializer is init with frame. So what image view is going to do is look at that image, check what its size is, and call the super designated initializer with a rectangle that's that size, 0, 0, origin, that size. Okay, so it's going to call super init with frame from that initializer. You can change the image that's in a UI image view at any time. It's got this property called image, and you just say, image view.image equals any UI image object, and it will change it. Now, one thing is it will not change the frame, though. Okay, the frame, the size of your UI image view is set at the time you create the UI image view. Now, of course, you can set its frame too. It's a UI view. It's got a frame property. You could set that. But I'm just saying, putting a new image in there is not going to have it resized to a smaller thing. So, like, if you put it in your view and it's a certain size, 200 by 200, and then you put a 100 by 100 image in there, it's not going to shrink down to 100 by 100. Of course, the image displayed is going to be a smaller, but this rectangle in the view rectangle is going to continue to be large. UI image view has a lot of other, question.
What if the UI image is larger than the screen?
Then it'll get cropped. The question is, what happens if, if it's larger than the whole screen? Oh, we're going to talk about that at length in the demo today. What happens there, what the options you can do. So we'll get to that. So what other things can UI image view do besides just display one image? Well, it can also have a highlighted image, and then you can set a property highlighted, and it'll switch between the two images, which is great for like a button or something like that. You set a button, you want it to be in a highlighted state. You can just say set highlighted, wham, it uses the highlighted image. It also actually can animate a sequence of images, which is really cool. You pass it an array of images, and then you pass it the duration over which you want those images to animate, and then you can specify how many times you want it to repeat, and it'll just sit there animating through those images. Right? In the background. Your main thread won't be blocked. You can be off doing other things, and that little image will be sitting there animating those images. Very, very cool. If you want to put a little, dancing guy or something in your view hierarchy, very, very easy. And you can start and stop the animation with these methods, start animating and stop animating. So UI image view, pretty powerful class for displaying images, UI images. All right, this other powerful class, UI web view, it's a view, just like any other view, and basically it's an entire internet browser in a view. Okay, it can display, short of Flash and a couple other plugins and things like that, it can display dynamic HTML, JavaScript, all that, pretty much most web pages. And the UI web view also might be something you want to use if you want to display a PDF file or something like that. Okay, because it knows how to do these various embedded types that are on certain web pages. So it's a great way if you just want to display a PDF. Just you get a UI web view, pass it a URL for a PDF, even if it's local in your file system, it'll work great. So it's very easy to connect a back button, a reload button, forward button, etc. To the UI web view, and I'll show you how that works. The underlying HTML rendering is based on this thing called WebKit, which is an open source HTML rendering framework. It was started by Apple, but now it's been made open source, and many people are contributing to it all the time, fixing HTML rendering bugs, adding new features, etc. It's very easy to tell to load up a page. I'm going to show you how to do that. And it also has a delegate, and the delegate lets you kind of control the users clicking and also observe what's happening when users are clicking on links inside of the web pages that you're showing. And it supports JavaScript, It does limit you to 5 seconds of running time for any JavaScript, and also it won't let the JavaScript allocate more than 10 megabytes of memory. You can see why it puts those restrictions on there. You don't want your app to put up a web view and then all of a sudden it freezes because some errant JavaScript is running out of control. So, all right, so how do you load HTML up into this web view? So you create the web view, just drag it out in Interface Builder, or you alloc in it with Frame. And how do you load it up? Well, there's 3 different ways, basically. There's load request. You pass it a URL request. I'll talk about what a URL request is. And it'll just go load up the HTML or PDF file or whatever from that URL. There's load HTML string, which you can actually just provide a string of HTML. Now, people want to say, why would I do that? Provide an NS string with the HTML in there. Well, actually, it's kind of a cool way if you want to put some bold text or something, you know, some kind of short piece of text that has italics and bold and formatting in there. Do it all in some HTML editor, capture it, put it in a string as a constant string maybe, or in a database or something in your app, and then use a web view to display it. So you can think of it as kind of a UI label that can do all kinds of you know, fancy tricks with underlines and fonts and things like that, but you have to create the HTML to do it. So that's why we have load HTML string. And then there's load data. Load data is for loading arbitrary things that come from, blobs of things that come from the internet, usually embedded in a web page, that are described by a certain MIME type. And I'm not going to go into a lot of that today. MIME was originally created as a way to have email attachments and have them open up. So you have attachment that's a PDF file, a Word document, etc. And the web view supports a surprisingly large number of MIME types. And you can look at the documentation to see what all that is. Notice this thing base URL that's on both the load HTML string and the load data. That's just the URL to, relative to which all the relative URLs inside of the HTML string are relative to. I think I said relative 4 times there. But I think you understand what I mean also. And then MIME, I talked about MIME. Yeah, so the question is, can I load a URL which is just a file in my resources? Absolutely you can. It's very common to want to do that, to have a file somewhere in your file system. We haven't talked about the file system on iOS. We're going to next week. We're going to talk in detail how to load files out of the file system, what your file system looks like from the point of view of your app. But definitely you would imagine you could have HTML files in there and you would create a URL that points to it. In fact, I'm going to show you what that URL might look like. So NS URL request is basically just a URL, but you add 2 other pieces of data, which is the URL request cache policy and also the timeout interval. Because if you're loading something off the internet, you might want to give up after certain time. But otherwise, it's just a URL. And you can see that the class methods here which return auto-released NS URL request, by the way, they take a URL, and then there's a version that takes these extra arguments if you want. NS URL looks very much like NS string, except for that a URL has to be well formed. So here's a couple of example URLs: file:// something in your file system, http:// something out on the internet. That's what a URL looks like. You usually create a URL, an NS URL, by creating an NS string that has http:// cs193p.stanford.edu/ something, and then you say NS URL with string. You pass it the string, it passes back URL. If it was malformed, you might get back nil, for example. And then you asked about what if I have a HTML file in my resources or my file system. Then there's, for example, file URL with path that takes a file system path and returns a file URL. And this is actually the preferred way even to just do files. All right? So generally, there are some methods, I believe, still left in iOS that say do something with a file, and here's an NS string for the path. But really, there'll be a similar method that's the same thing, except for it takes an NS URL as an argument. And really, that's the one you're supposed to use. Okay? Is NS URL-based ones to specify files and web URLs. And then this NS URL request cache policy thing, that has a bunch of constants for things like ignore the local cache, the local web cache, or ignore caches that are out on the internet. I want to go all the way to the server. Use expired caches. Normally it wouldn't do that. Use the cache only. So presume I've looked at this page before, just whatever the last version was. Or use the cache only if it's validated, this whole validation mechanism for loading HTML. So that's what the request cache policy, URL request cache policy is. And you don't have to specify. You can see the top one. You just say, here's the URL, and it defaults to sensible things. I told you it was easy to put back buttons, forward, reload, things like that. These are the properties and methods you would do to find out, for example, is the thing in the middle of loading this web page, is the back button, can it be enabled? In other words, is there a place to go back? And then obviously these methods, go back, go forward, reload, etc., that you can imagine what those would be hooked up into in your UI. There's also some methods for controlling the display of the web view, how it displays. Probably the most commonly used one is scale pages to fit. And if that's yes, then when it loads an HTML page, it scales it so the entire thing fits inside the web view. Now, you might result in very, well, actually, I shouldn't say the entire thing. Probably it scales it so that, for example, the width will fit. And then it'll still be in a scroll view. You'll be scrolling up and down. But the point is that the text can be really small on an iPhone if you have this to yes. The default is no. So a lot of times you want to turn that on, not always. And then it also has this kind of cool data detector thing where it'll look in web pages as it's parsing them, and if it sees something that looks like a phone number, it'll make it a link. And you can click on it, and it'll dial the phone on your iPhone. Okay? It does also with other, it can detect obviously links to other web pages, an address or calendar event, and you click on them, it'll launch your calendar app or whatever. Okay, so that's kind of fun. So usually we turn those on, but you might not want to. All right, so the delegate of UI web view, what is it? What things can it do? It'll notify you when it starts loading. Okay, so should start load with request, so it tells you the URL request. That might be something that you told it to do, but more likely it's a link that someone clicked in a web page that came up. And this navigation type tells you what kind of thing caused this request to happen. Because it might be a link being clicked, but also maybe someone submitted a form. You know how HTML pages can have forms, and you submit them. And so that might be a form submit. And you might not want to allow forms to be submitted. Okay, and then you can stop it, because this returns a bool, which is whether you should start loading it. There's other things, tells you when loads start and finish. It also tells you when loads failed and the error. So like, you know, it might be a network error. That's a common one. You start loading an HTML page, network error in the middle, it fails. The delegate would be notified there as well. Okay, the next UI view of the day is UI scroll view. Super important view. It is the superclass of some very important views. What you use it for is anytime you have a view that's too big to fit on screen, like a UI image view that's just too big. Big, gigantic image, won't fit on screen. You don't want to have to go implement pinch and pan and all that yourself. You'd like to just throw it into a UI view that does all that for you, and that's what UI scroll view does, and that's what we're going to do in the demo today with the UI image view, is add it to a scroll view. So that's what it does. It is a UI view. All of these three things that I'm talking about are just UI views. They're rectangular areas on the screen. Scroll view just happens to scroll and pan and zoom its subviews. All right. The way it pans and zooms is around a predefined size. So it has a property which is the size of the area you're scrolling around, which may or may not be the same size as the subviews that you're adding to it. Okay, and maybe you're only going to add one subview and it's the exact same as the area it's scrolling and panning around. That's common. But it's important to understand that you don't add the subviews and then it scrolls around in the subviews. What you do is you set a size and it scrolls around in that size. And then when you add subviews, they'll appear, if you set their frame right, in that content size. So I got some images to show that. And there are two very important subclasses of UI scroll view. One is UI text view, which is kind of like a UI label, except it's editable and it's scrollable. So you could put a real big text in there. Pages and pages of text could go in there. And then UI table view, which we're going to talk about on Thursday. Massively important view, and it is also a subclass of UI scroll view. UI web view, it scrolls. I don't think it's actually a subclass of UI view for reasons beyond my understanding, something internal to Apple, obviously, but it acts as if it were a scroll view because you load up a web page, and if it's too big, it lets you scroll around. So what are some examples of UI scroll views? So Google Maps, when you load that up, that's in a scroll view. It's kind of an odd one because it's infinitely sized content area. So how does that work? Because you can't specify infinity when you specify the size of the scroll. So it's not infinity, really. It's just the entire surface of the Earth. But how does that work? Well, it's futzing with that size behind the scenes all the time. But it does it all for you. Here's one where it's the camera roll, which this is an interesting one because if you pinch down on it, it'll actually show you a whole bunch of photos. And then when you zoom in on one, it's only showing you one. So again, it's kind of futzing with the content size, so it's kind of a goofy one. Here's a kind of a normal UI scroll view, a UI text view actually, which is the notes here that you type in. And if you type in enough notes, it starts scrolling. And there, when you add more text at the bottom, it's resizing the content size that it scrolls on to be bigger and bigger to fit the text. And so scroll indicators, rather, will start to appear if you started to scroll. Here's a table view inside a tab bar controller you probably recognize. We're going to talk about table views on Thursday. And here's an interesting table view, actually, that's in a scroll view, which is the clocks. If you add enough world clocks, 10 or 11 of them, it'll start scrolling up and down. This turns out to actually just be a table view right here, and the lines in the table view just don't look like a normal table view. They're not text. They're kind of a custom drawing view, which we'll talk about on Thursday as well. So there's a bunch of examples of scroll views. All right, so I'm going to quickly go through the geometry here. It's pretty straightforward, really, and you're mostly going to just have this thing of the size is all that matters. But there are some little things you can do to do unusual things in the scroll view, which I'm going to go through quickly. So the content size. So this view on the right, it's kind of confusing, and I apologize for using that example. That's one view. Okay, that's not a whole bunch of little views with photos. That's one big view. It says 30 photos at the bottom, and it has a whole bunch of UI images drawn in it. But it's one view. This is one view. So what is the content size of that view of the place? Sorry, what is the content size that we're going to be scrolling over? In this example, I'm going to set it to be the size of my view, which is very common to have one view that's your scroll view, one subview in your scroll view, and your content size is set to be the size of that view. Very, very common, probably the most common use of scroll view, as you can imagine. The frame of each of the UI scroll view subviews is relative to this content space, with upper left corner being 0, 0. So when I add this big view to the content space, when I add it as a subview of the scroll view, its frame now, remember frame is the bounding rectangle view in its super view coordinate system, in other words, in the scroll views coordinate system here. Its frame wants to be 0, 0 origin, content size.width, content size.height. That's its frame. So I've added it to completely fill the content space, content size of my scroll view. Also, usually, and as I said, usually the UI scroll view has only, this is what I just said, it usually only has one. Origin would be 0, 0, size would be the scroll view's content size. Okay. Now you could add a bunch of other subviews in there, and if you set their frame, they don't even have to be 0, 0. You could put them around in the content space anywhere you wanted, but no matter what you put in there, it's only going to scroll around the content size, this property content size, 0, 0 origin. Okay, so here's a little iPhone. See, it's scrolling around, right? And it's just moving around. And so okay, so that's the basic setup. So I'm going to talk about this thing that you're going to see in the API of scroll view. You're going to say, what the heck is that? Called content inset. And content inset is for this special thing, okay? So I've taken my content and I've added a little bit at the top and bottom, and the amount I've added is content inset.top and content inset.bottom. Now why would I want to do this? Have a little blank space at the top and bottom? And the answer is this weird kind of UI. You see that little translucent thing at the top there, that title bar, like a UI navigation bar thing? It's translucent. So when I scroll my view down all the way, I want my entire content area to be visible. And so I'm putting this extra little thing on the top to be behind that translucent thing. And similarly, I can do it at the bottom. If I have a little translucent thing on the bottom, I can scroll it up. Kind of goofy. You're probably never going to do this. But if you see content inset, I just don't want you to be confused between content inset and content size, and the next thing I'm going to talk about, which is another one. So that's what that's for. Next is scroll indicator insets. So can you see the scroll bar in the lower right-hand corner there? A scroll indicator, actually, it's called, not scroll bar, scroll indicator. Watch, I'm going to scroll this thing up. You can see the scroll indicator moved up. But look, it moved all the way up into that translucent area. So I don't want that. So I can set the scroll indicator inset of that thing to move it down, right? So that's, I would only use the scroll indicator insets probably with a content inset. And you can also do it horizontally. You wouldn't do it in this case, but you could. So it's basically insetting the scroll indicator offset from the proper position it would be in the scroll view. All right, that's enough of that. So here's the important ones, though. Here's an image I have. You can see the content size, height and width, and then I've got this little content inset. There's another thing called content offset. And I know this is confusing. You got content size, content inset, content offset. That's why I'm going through this. You can refer back to these slides. Content offset is an interesting one. It's a size. You can see a CG size. It's the offset of the visible area in the scroll view in the content area's coordinate system. So for example, in this case, the content offset would be the little x and the little y. Notice that it's relative to the content area, not those content inset things. The content insets are extra. And in fact, if I looked up here in the corner, let's say I had some translucent views on the top and the left, I guess, then my content offset could actually be negative by the content inset because it's all relative to the upper left corner of the content size. So, okay, I've done my responsibility to tell you about all that. You can probably forget it. Content size is the important thing for you, okay? Content size, that's the area the scroll view is scrolling around. The other thing I want to say that I didn't put on a graphic that's really important, especially for your homework, is some people say, how do I find the rectangle that is the scroll view's visible area? Okay, the part of the scroll view that's showing on screen. And that is the scroll view's bounds, right? Remember, bounds is the area you draw in your own coordinate system, as opposed to frame, which is your super view's coordinate. So the rectangle that the scroll view is showing, that's on screen, that's visible, is the scroll view's bounds. And your homework assignment asks you to kind of make some mathematical calculation between the scroll view's bounds and the content size. Okay, so that's really what you think. Now you don't have to do any of this content inset, any of that business for the homework. Okay, it's scroll view's bounds, content size. That's a big hint for the homework. All right, so scroll view. How do we create a scroll view? Just like any other view, we drag it out in Interface Builder, or we can alloc init with frame it. Okay, so for example, here's a scroll view, some code that creates a scroll view that fills the entire screen that I'm allowed to fill. In other words, not including the little status bar at the top. I get the application frame, which I talked about earlier. I do alloc init with that frame, and then I just add subview the scroll view. It's a view, so I just add it. Okay. Then, once I've got my scroll view on screen, or it's in a zip file or something, then I just add my too big view that I want to scroll around in to the UI view as a subview. So here, for example, I've created an UI image from a file bigimage.jpg. It's big, and I create the UI image view. Presumably, it's too big to fit on screen, which was a question asked earlier. And then I just, oops, that is wrong. It says subview, add subview. That should be scroll view, add subview, image view, right? So I just add it as a subview to the scroll view, and I can add multiple. And then, and I can do this before or after I add the subviews, I set the content size that my scroll view is going to be scrolling around. Okay? And here, I'm going to set it to be the size of my image, right? Image view .bounds.size, that is the size of the image view. So what else is there in this UI scroll view class besides positioning, like content offset, content size, content inset? You can control the bouncing. You all know what bouncing is in scroll. That's like I flick with my finger to scroll, and it scrolls too far and bounces back, right? That's the bouncing. Same thing zooming. I pinch in, it pinches too small, smaller than the scroll view will allow, and then bounces back up. Or I do too big, and let go, and it bounces back in. So the bouncing is kind of a visual indicator to the user that you've exceeded the bounds or the limits of this scroll view's ability to zoom or pan. And so I'm going to bounce a little bit in your vision. You can turn that off. If it's not really appropriate to your view, you can turn it off, both for zooming and panning. You can constrain the scrolling. You can disable the scrolling at any time by saying scroll enabled equals no. It also has this constrained scrolling called directional lock, which is once you start scrolling significantly horizontally, you'll only be able to scroll horizontally. Or if you start significantly vertically or horizontally, if you start significantly in one of those two ways, then it'll constrain it to only do that. So if you have like a grid or something and someone's scrolling horizontally or vertically, it'll kind of keep them in the column that they're in. If they start substantially diagonally, it'll scroll freely, vertically and horizontally. The scroll view can also control the display of the scroll indicators. There's an important one here called flash scroll indicators. It's just a method you send to the scroll bar, or to the scroll view. You should pretty much do that when the scroll view comes on screen. Because if the scroll view comes on screen and there's scrollable content, you want to give the user a little quick indication, oh, there's more. You could possibly scroll. So you just flash those scroll indicators, because the scroll indicators don't appear otherwise. They don't appear until you start touch and drag. And there is a couple of different kinds of scroll view indicator styles. You can look those up. Now, can you programmatically scroll around? We know that the user can use touches to pinch and scroll around. And the answer is, of course you can. The way you do this is you send a message to the scroll view saying, scroll this rectangle in your content size to make it visible. And it'll do the minimum amount of scrolling to make that rectangle entirely visible if it can. Okay? Might zoom as well, right? If you say a big one, it might zoom in there too. I think it'll zoom. But the point is, this is how you can kind of get things to appear on screen. Okay, so here's kind of a fun example of scroll views doing the directional lock. See how it knows whether you're going horizontal or vertical there. So that's kind of a fun thing. Here's another one. This is a scroll view in a scroll view, actually. It doesn't really show this part of it, but the top part can have more stocks, and then you can have scroll views within scroll views. And notice that the bottom one will go horizontally or vertically. So scroll view, pretty powerful. It knows how to work inside other scroll views. It's a pretty powerful class in general, and used a lot, obviously. All right, so that's kind of the scroll view panning around. What about zooming, this pinching in and out thing? The way zooming works is every UI view, and I'm not sure whether I mentioned this earlier in the class, but every UI view has a property called its transform. It's an affine transform. For those of you who have not taken some basic graphics, an affine transform has three things: a translation, a scale, and a rotation. So every view has that, and you can modify the affine transform by doing any of those three operations, and the view will just figure it out and draw it. Now it's going to do it at the bit level. Okay, so if you scale, you're going to have big pixels, right? If you rotate, it might be a little grainy, depends. But the way zooming in scroll view works is it modifies your affine transform, okay, by scaling it. So you wouldn't, generally zooming in a scroll view, we like to start things big and have it zoom down. You see why? Because when I zoom down, I'm not making my pixels really bad resolution. If you start with something small and you let them zoom it way up, it might be look bad, it might not look crisp, etc. So usually zooming is to zoom down. Zooming will not work without two things, so pay attention here. You must set a minimum and maximum zoom scale. Okay? The scale system here, 0.5 for example, would be half its normal size. So you could zoom it down to being half its normal size. If you said 0.1, it could be a tenth of its normal size. Okay? And then maximum zoom scale is a number like 2, which would mean you could zoom it up to being twice as big as its normal size, or you could have 10 and be 10 times as big. Okay? So that's how the scale system works. You must set the minimum and maximum scale. If you don't set them, you can't zoom. And it will not work unless you implement this delegate method. Because the UI scroll view has a content size, and inside the content size there could be lots of subviews in there. When it comes to zooming, you have to let the scroll view know which subview you want to zoom. Okay, which subview do you want to modify its affine transform to scale? All right. Now, my take is, it seems to me you should get away with not implementing this delegate if your scroll view only has one subview. But you can't. Okay, you have to implement this delegate method, return that one subview so that it can zoom. All right. A lot of people forget this part. There is another delegate method of the scroll view which will notify you when it's finished zooming, which view it zoomed, and what scale it ended at. One thing to note here, if you allow the scroll view to pinch, remember that it's modifying this affine transform. Like, let's say you had your graph view, and you put your graph view in a scroll view, and the person's scrolling around. When they pinched in and let go, and change the scale, you might want to redraw your graph view because your graph view is really good at drawing itself at different scales, right? It knows how to perfectly redraw it using every pixel. You wouldn't want, you know, a pixelated, you know, yucky, bad resolution graph. But when you do that, it's okay to tell it to redraw, do a set needs display on it, but make sure you set your affine transform identity back to 1 because the scroll view, when you do that, is going to change it. And there's an identity transform. It's really easy to say view.transform equals identity transform. How about programmatic zooming? We talked about programmatic panning. Two ways to do that. One, you can set the zoom scale. So you can set the zoom scale to 2, and it'll get twice as big. Another way is to zoom a rectangle to be visible on screen, similar to the other scroll to rect. Actually, I think, yeah, okay, so I think I said that other scroll to rect might zoom. It doesn't. The scroll to rect only pans. Zoom to rect is what you need if you want to zoom. So let me show you a little graphic how that would work. So here I've got an image. It's big. Its zoom scale has made it larger than it normally is. Now I'm going to go back to zoom scale 1. Okay, so there's zoom scale 1. Now I'm going to go back to zoom scale 1.2. You see how I'm zooming in and out, down to 1.0, it's its normal size, up to 1.2, okay? So that's just the normal setting the zoom scale. You notice there was a set zoom scale animated as well, and that does the same thing. It does the same scroll view.zoom scale equals, but it will animate it. So it will, you know, show you the in-between locations. So here's how the zoom to rect works, okay? You specify a rectangle, like here I got the nose of this gargoyle, and I say zoom to rect on that rect, and it will zoom it up as big as it can inside the scroll view. Okay, now it won't exceed the maximum zoom scale, and if we're going down it won't go lower than the minimum, but it's going to zoom it up as big as possible and have the rectangle fit. I think it'll do the minimum panning to make it fit as well, so it'll zoom it up to fit and then just leave it there. It won't like move it to an edge or something. Minimum panning, minimum zooming. So what if I had a rectangle that was big? So I can use zoom to rect to zoom down as well, right? So zoom to rect is a good way to basically say to the user, if the user is interested in a certain part of the content area the scroll view is scrolling on, zoom to rect, you can get the whole thing on screen, okay? All right, what other delegate methods? There's a whole bunch of delegate methods in scroll view that tell you when it's scrolled and when it starts decelerating, if it's doing this thing where you flicked to scroll and it's scrolling a whole bunch and then it starts decelerating. Okay, so it'll tell you all that. Obviously, a lot of that stuff way beyond what we can cover in the time allotted. You can also find out what the scroll view is doing here, whether it's in the middle of zooming or in the middle of dragging. It's in a deceleration mode from a flick, etc. So that's image view, scroll view, and web view. And the demo I'm going to do here, this is a real dirt simple demo. I'm just going to create a new project, and first I'm going to create an image view and just throw it on screen. It's not going to be scrollable. Then you'll see it there. Then we're going to add a scroll view and put the image view inside the scroll view, and I'll set a couple things on the scroll view. We'll make it so the scroll view can zoom. That's all we're going to do. Your homework's due tomorrow as usual. This is the coming up slide, so that's coming up. And then the next lecture on Thursday, I'm going to talk in detail about UI table view and UI table view controller and all the other UI table view, this, that, and the other classes, which is a super important scrollable view for building complex user interfaces. All right, so that is it. So let's do the demo here. I'm going to put this up here. I'm going to try and just do this right here. without a mouse or anything, so pardon my difficult typing. All right, so I'm going to create a new project. It's going to be a window-based project. I'm going to do all this stuff in application did finish launching. Of course, you wouldn't really do that. You would probably create a view controller and all that stuff, but we're just going to, I just want you to see what the code looks like. I'm going to call this Imaginarium, okay, because it's an image view thing. So here it is. Here's my Xcode project. I'm going to hide others. We need a view, we need an image, so I'm just going to go out on the internet here. Let's go to, let's say, apple.com. They have a lot of cool images there. Maybe we'll take this image right here. I can, how do you do this? Save image to downloads. Okay, so we do that. I got my downloads here. It's this one here, iPod Touch 2001. So let's go over here to my downloads. And I'm just going to drag that image into my resources so I can do it by name. And actually, I'm going to change the name because it's such a long name. Let's call it iPod.jpg. All right, so I'm just going to pick this up, dragging it over here. I'm putting it in resources folder. Let go. It's going to ask me if I want to copy, which I do. Okay, otherwise, it's just going to have a reference to that in downloads. And next time I clean out my downloads, it'll be gone. So there's add. So here we got this gigantic image here. So I'm just going to go to my application, did finish launching. First of all, let me run this real quick just to remind you what an app looks like when you run it and you haven't done anything. It's just blank. So all I'm going to do is in that white area, not where the status bar is, I'm going to put that image in. So let's just do that. I'm going to go up to my classes, make this a little wider so you can see this. I'm going to application delegate.m. Close that. Just bigger. All right, and so here's application, did finish launching with options, right? We have no view controllers or anything here. So this is where we create our initial user interface. So I'm going to create that UI image, and the way I do that is I'm going to call it image, let's say, equals UI image, image named iPod.jpg. Okay, so now I've created a UI image. Now I want to put it on screen. So I'm going to create a UI image view. Call it image view equals UI image view alloc init with image image. Okay, so it's created a UI image. Its frame is going to be set to 0, 0, width and height of that image. So now I'm just going to window, add subview, image view. Okay, and that's it. So let's take a look, see what happens. Okay, so there you can see it has added it. It's put it at 0, 0, which is kind of a weird place to put it, actually. It's probably behind, it's not a very good image to show this, but it's probably behind that status bar, which is really not where we wanted it. The right place to put this is in the application frame, right, to use the application frame. But let's, for time conservation, I'm just going to go straight to putting this in a scroll view. So let's do that. So I'm going to go UI scroll view equals UI scroll view alloc init with frame. Okay, that's UI scroll view's thing. And I'm going to put this in the application frame. So let's get that. CG rect application frame equals UI screen, which is a class that tells you information about the screen. Main screen application frame is a method on there. So I'm going to ask what the main screen's application frame is. Then I put a scroll view in there. I'm going to set the scroll view's content size. So always must do. You must set the scroll view's content size, or otherwise it won't be scrolling on anything. And I'm going to set it to be the image's size. Okay, the size of that image that's in my image view. I could also probably say image view dot bounds, for example, but we'll say image dot size. And then I'm just going to scroll view, add subview, that image view. And then instead of adding subview image view, I'll add subview the scroll view. Okay? I think that's done all the right things. Let's see if that works. All right, so there's our image, but now we can scroll. Okay, see? Scrolling around. We can do this thing. It kind of bounces. You see the bounce there? Try and flick it. It bounces a little bit. Same thing down here. Bounces. So let's turn that bouncing off just so you see what that looks like. So instead of making it bounce like that, I'm just going to have it stick to an edge. And so that's real simple. I just say scroll view dot bounces equals no. All right, so now let's see what that does. Okay, so now when I scroll, see, it doesn't bounce. There's no bouncing. Okay, if I flick it, it just stops at the edge. So you see the bouncing? You can do the same thing for zooming, turning zoom bouncing off as well. Okay, so speaking of zooming, let's do zooming. So remember I told you there's two things you have to do for zooming. One is setting the minimum and maximum zoom scale. So I'm going to say scroll view, minimum zoom scale. Let's let it go down to a third point or 3/10 of the size. Well, let's scroll down to that. And then the maximum I'm going to allow is, let's say, 3 times as much. So I'm going to let it scroll, zoom up to 3 times as big, zoom down to 3/10 as big. Then the second thing I said you had to do besides setting the maximum and minimum zoom scale is implement that delegate method. So I'm going to set the scroll view's delegate to be self. In other words, the application delegate. So I better go to the application delegate here. Make sure it implements UI scroll view delegate. Then we'll go over here, and then we'll just implement this method, which is an easy one. It returns the UI view that you want the zooming to happen in. And it's called view for zooming in scroll view. And I'm going to return the image view, but that means I need the image view to be an instance variable. So I will take it out of there, put this here, UI image view. Okay, I could make a property and all that stuff, but for expediency here, I'll do that. So everyone see what I've done here? Pretty simple. So now zooming should work. Let's run this. All right, so we can still move around in it. Still no bouncing. But now if I do this magic, hold down the option key, I can also zoom. Okay, and notice that I zoomed small, but then it bounced back up to 3/10 of the size, which is the minimum I allowed. And same thing here. Let's zoom it up. Okay, we can't bounce any bigger or zoom any bigger than that. Okay, so that's pretty much it. Scroll view, image view, really easy to implement, really easy to use, very, very powerful. You will be doing this in your next assignment, not this one that's due this week, but next week's one. You'll have to be putting an image view with some image data you get over the internet into a scroll view. All right? So that's it. I'm done early today. How about that? And then, again, on Thursday we'll be doing table view. I'll be here after class today, so if you have any questions, feel free. And if you don't have any questions now, that's it. We'll see you next time.
For more, please visit us at stanford.edu.